carbon free. We have offset the carbon by your arrival of the workshop. The requirement from our friends from abroad by improving food stocks in Kenya. So I want you to feel that this is a workshop your position should be addressing these things. Also, outside there are still some leftovers from lunch. If anybody is practice, they can go out and go somewhere else to fix something. And having said that, I leave it to the good help of my friend Frode, who will be able to win in all its aspects, so that you know how you manage your win the best possible way for that. Frode.
Okay, thank you very much. During the next hour or so, I will talk about Bazefield and the new management system that we have. But before we do, I want to make it show the product, show the software, just seeing it really. But before I do that, I want to make a few slides on the company. Okay, is this better?
Yes.
Everyone here? Great. So, Bazefield. We are a Norwegian-based company. We started back in 1991 doing integrations. And even though I hate to admit it, it was in the oil and gas industry. So we did that for quite a few years, various types of integrations. And then we, in around year 2000, we started developing products. Instead of being a consultancy company, we did start developing products. And in 2008, we got invited by Statoil, which some of you probably know. They had an ambition to go towards renewable. We were lucky enough and probably had good products since we've been working with them in the oil and gas industry. And we got invited by them to do a first pilot in 2008. So that's where it all started for us. We do have still business critical installation in oil and gas. We do not just leave them as customers. But we only focus in the renewable area as we speak. So since 2008 we started with the first pilot, and today we have more than 300 sites in operations around the world. Yes. Okay. We have a very tough ambition. We say that we have that our goal is to be the best global supplier of operation management systems. So that means that we put a lot of effort into this, both investments, but also passions, and the people that are working for us is very passionate and eager to develop this to be the best at all times. We started, as I said, in renewable. We have various installations both in wind, but also solar, and we do hydro. We do various other type of techniques or areas. But the general platform is generic. It's been used through, as I said, oil and gas, also other industries. But today, it is an off-the-shelf product which you can install either internally in your own server infrastructure, or it could be in the cloud, either Azure, or it could be private cloud. We have, I think we have all the different variations that is out there. So, just to tell you a little bit, when it started as a pilot in 2008, this is the growth that we have had the last years. As you can see, we're closing, or we even passed the 14 gigawatts installed, and we are growing. So, just a very quick look at where we are at the moment. Of course, we have a main office in Oslo, or close to Oslo, in Norway. We have an office in London, and we have also 3 people in an office in San Diego in the US. And then we have partners like 3D here is one of the really big partners that we have, and a very good one when it comes to technology. And as we have seen on the technical presentation earlier today with forecasting and such, that's what we collaborate with. In terms of countries, we have quite a lot of countries. The US is the biggest, not necessarily in the terms of number of sites, but in terms of megawatts, because there are bigger farms over there than in Europe in general. These are some of the clients that we have. Just run very quickly. Leave the sales pitch and explain a little bit on Bazefield as a system, because Bazefield is a system that is basically divided in 3 parts, as you can see here. So the lower part is the plugins, and I got a few questions during the lunch break regarding the technology and how you can plug and how you can set this up. So I added a few slides here just to give you an introduction on the technical side, and then I'll move on to the demo. Okay, so the lower part here is plugins, and we are an overlayer of the SCADA system, and it's it could be from various sites, of course, your entire portfolio, but it can also be not just the OEM, it could also be the substation, the metering at the site, any data that you want stored from the site. We normally install a small rugged computer as close to the data source as possible, just to have the best data integrity possible. And that can communicate on various protocols, real-time or through SQL Server. Take that as an example. So we have all these plugins, and we can do this for the entire portfolio. And the way that we do it is that it's very object-oriented, so that you have your own models. We will take responsibility for that, of course, so that it's easy and quick to configure and set up. But it also includes calculations and performance indicators, so that you can compare between the sites as a generic independent system. So, if you have any questions, feel free to interrupt me. I'm open to any question. So typically, this is the structure that you have. You have all the sites close down at the very bottom there. One small computer on each side, just collecting the data, compressing the data, send it in real time to the master server. If you lose communication, we will handle all that automatically so that you will have all the data in your master server. We do not degrade any of the data. We will keep it with the highest resolution that we log. So typically for a SCADA that's between 1 and 10 seconds, we will log that data and we will keep it for the entire lifetime of your wind farm or your solar farm. That's important because you really don't know into the future what kind of analysis necessarily that you want to do in the future. So it's important that you have high resolution or the highest resolution available. The highest resolution we log directly is 25 hertz, but we can log up to 1000 hertz if you're really into research projects and so on that researchers needs higher resolution data. The system is very scalable. You can scale it in any direction. So from a user's perspective, it's only one system. But on the back side, there can be multiple servers depending on the size of your portfolio, of course. But it can also be in terms of the high resolution logging. So if you're logging, take an example, 25 hertz, that generates terabytes and terabytes of data. So you don't want to mix that with operational data, so you can split it in two. But from a user's perspective, it's one system. Another thing that I wanted to mention before I start looking into the software itself is the interfacing, because we also have built-in redundancy in the interface. That means that often there is different sources available for your wind farms or your solar farms. You can have real-time, such as through OPC or the 104 protocol or any other protocol that is out there. We can connect to that as the primary source. Then again, if you have the SQL server, which is very often available with 10-minute averages, that could be the second source of information. We can log that in parallel, or we can set it up so that whenever you lose communication, if you lose communication with the primary source, then you switch automatically to the secondary source. And we will backfill then all the data automatically, and we do calculations just to have the best data integrity possible, basically. And that's, I think, is an important issue as well, that you keep focus on the data integrity and that you store as much data as possible. I just want to mention now, before I go to the demo, that there is also available, the software contains also mobility, meaning that there is an app on App Store that you can download, or is also tailored to iPads if you prefer that for the technicians on the sites and so on. Having said that, I think I'll just switch to the demo. So what I plan to do now is just show you a little bit on the system itself. Any questions regarding technical issues or server, whatever type of technical stuff? I noticed that there were a lot of people from the presentation round that were from these type of integration issues something that you're familiar with or struggle with? I assume so, because for which one was that?
Usually technology which have fantastic more common find problems in time.
Yeah. Yeah, we were kind of surprised when we came from the oil and gas industry, right? So they heavily invest in, I mean, downtime is not allowed. It's not, if you have multiple downtime, that's not acceptable. That's just the way it is. So going to the wind industry after that was kind of a surprise to us, because that kind of happened frequently, and no one seems to really take responsibility for that. And if you look at the protocols, if you look at OPC and the compliance to the OPC standards, that's not often the case. That it's not always 100% to be authorized on that. But there are different ways. I think we've been working with this, and the background that we have built in these kind of mechanisms to always keep track on and keep making sure that we have communications and so on. For example, if you have a flat line, I think one of you, you mentioned that you have Nordex, was it not? One of you had Nordex.
We did.
All right. So I remember that we had a lot of problems with Nordex in the OPC server. That's just the way it is on that particular site. So you had flat lines, right? Suddenly it just stops communicating. You have perfect connections, but you don't have data. So what do? You have a perfect connection, but you don't get data. So what we do is that we built in mechanism just to, if you get a flat line, if wind speed is constant for 30 seconds, you know that something is strange. So you can build in mechanisms to trigger that over again, try to kick it back again. And then if that doesn't affect in say 3 attempts, then you can close down the entire integration and then take it up again, just to try to get it back online. So these are the kind of mechanisms that we, through the years, have built into the software in order to have that data integrity. And if that don't work, then you can switch to the secondary source and so on. So we've been using a lot of effort the last years just to have that data integrity. Okay. So this is the Bazefield portal, and as you can see, this is kind of the introduction to your assets, both real-time and historically. To the left here, you will see a menu, and the menu is kind of how we divide the system into different parts or different modules. And we have a monitoring part, we have analysis applications, we have some operational applications, we have a module for condition monitoring. There is a module for more performance follow-up and some dashboards that has been tailored for owners. And also reporting, of course, is important. So I just wanted to give you a quick introduction here. This menu and these screens can all be built up by privileges. It means that depending on the role that you have in your organization, the menu can be appearing differently from control room users to management and so on. We also support, since I heard there was language was mentioned, we also have a possibility to change the language in case you you don't want English as the default installed language. Okay, so I'm diving into monitoring part first. This is a module that will give you an overview of the contents. These are all dashboards, so some owners like it this way, more graphical oriented. Some owners like it like a long list of your wind farms, more operational data. Some is very focused on budget numbers. They have budget numbers in there. I think the really important thing is that these kind of dashboards are flexible and that you can really change them over time, and that you can do this yourself. So in here in the portal, I can, if I have the privileges, I can turn this into edit mode, and I can tailor this exactly as I like. If I want to have an alarm log for certain, filtered out for certain areas, if I want weather forecast, if I want any type of visualization, I can basically just create these, and I can drag and drop these around if I want to make changes to the dashboards. So all the screens that I'm going to show you now is based on this technology. And as you can see here in the menu, you have a range of different widgets available that you can build your own, whether that's a map, that's real-time visualization, gauges, alarm log lists, table visualization, and so on. So you simply just click and you can drag and drop these around just to build your own dashboard with any information that you have available. So I think this is very important. We also build this using the high chart component, which allows you to do basically any type of visualization. Are some of you familiar with the high chart component from before? Okay, this is just a graphical component that you can set up and make use to do really advanced stuff. That's the way that the dashboard works. In addition to the dashboards, there are a range of applications available. This is one that is used for operation visualization. You can have all your assets, regardless whether that's inverters or that's wind turbines or whatever. So you can decide for yourself what type of assets that you're looking at and want to follow up on. You can also follow up on corrective maintenance if you're looking at only those turbines that are in stock condition, or if you want to follow up underperformance. That's very easy to do here, as we are looking for underperformance in real time. All of this is also available as statistics, so I will show you that afterwards. And also new now, in the new version, we can do condition monitoring, which is kind of calculations on conditions that you want to follow especially. So this is kind of a flag that comes up, and you can then go in and look at what kind of conditions has been triggered. And of course, these alarms can be either just in the graphical user interface, or they can be emailed out as notifications. So that's another feature in the system. I got a question regarding whether this system is also a control system. Yes, we do control some of the sites that we have in operations. We can either do it manually using the control functions directly from here. If you're looking at turbines in stock condition, you could try to start it directly from here if you have the privileges to do so. There are also some bit more advanced type of controls available. In addition to that, we also have algorithms for, say, bat control. So if there are active bats, you need to close down the turbines in some areas. So we do that automatically based on certain conditions. In some countries, there are very price sensitive, so you can get very low prices or even negative pricing. So in those cases, we have some sites that where we have price information in real time, and then if the price goes too low, we just close down the site. So that's another way of that we can control the system or the sites individually. So this is an application for following up. These are now the different wind farms. You can dive into each wind farm individually, looking at operational data. You can build these dashboards a little bit depending on the size of the wind farm, of course. So this is how it looks like by default, and then you can use exactly the same dashboard technology as I showed before to either change the type of tags that you want to have in there, or if you want totally different approach here, or even more graphical, that's very, very easy to set up and change. The system also normally just connects with weather forecasts. I'm just coming back to that afterwards, so I'm not spending too much time on that. These are screens built for each and every turbine individually, and as I said, you can create or you can set up. Some of the customers that we have also set up screens for different systems, like pitch and yaw would be the type of visualization. But the fact is that you can build these and you can tailor this to be exactly as you want it to be. Any question?
Yeah.
Yeah.
Just a question about this control function.
Yes.
What exactly can you do? Is this just a reset button, or can you reset the safety chain converter or whatever? What is it doing?
Okay. Yeah. Okay. So depending on the turbine vendor, because we integrate with a SCADA system,
Yeah.
and depending on the OEM and the turbine type, how old and new it is, the range of commands that you can do is different. Say range from 3 to 10 or something like that.
Mm-hmm.
So most of the cases, start and stop and acknowledge alarms is kind of the basic ones. But there are some others where you can set points and so on, depending on the OEM. So from a technical perspective, it's not a difficult thing, but it depends on how much commands that are available on the other side of the interface.
Do you have a list for each turbine, as example? This turbine can do this resets, etc.
For those that we have integrated, I can give you a list, of course. Yes. What kind of turbines do you have?
Especially Nordics.
Nordics?
Yeah.
Okay.
Old and new ones. N43 to N117 now.
Yeah. Okay. I'll need to take a look. I've not been working too much with them myself, so I'll have to follow up on that one. Any other question? Yep.
Because you detect and quantify the performance.
Yeah. When it comes to underperformance, it's not for us. It's not a matter of quantify it 100% accurate, like it will be in court, but for us it's more a real-time system where you can detect that something is wrong, it's not producing as much, and that you can do something about it. And the way that we do it by default is that we use the power curve, and I'm coming back to that, so you can use the power curve and you can train it over time, either on sector-based or, but using the power curve as the starting point, and that's the default setting, so that whenever you have an off 5% or something, then you will be notified, and then you can do statistics on it to see how often it occurs as well. So all of these are just monitoring, and you can do this, of course. We have also monitoring here on the different inverters, and just like we have a cooperation here with 3D, so we can either connect directly or we can connect through 3D using their plugins. They have a lot more plugins than we have. Just the fact that they have been working in this for a longer time than we have. But we have a good relationship, and we certainly have the possibilities here to do a lot of different presentations when it comes to inverters and so on. We can also make use of what we call a heat map to identify and try to identify performance issues. So that's another thing that has been developed lately. The heat map here is just on the demo service. It's not very useful data, but you get the picture whenever the color is such and such. For each of the inverters, you will see the color will change. Coming back to that in the wind part, but it just follows the same pattern as for the wind. Wanted to show you a little bit on alarms, because we integrate not just with a turbine SCADA, we also integrate with substations, we integrate with various other data sources. And all these have alarms. And this application here is a generic application which can handle alarms from various data sources. It could be communication issues, it could be condition monitoring alarms, it could be various other alarms that comes system. To the left here, you also have a filter, which is very unique and user-friendly. In the filter, you can select the time period, you can select the type of assets that you're working with, or certain farms and so on. So in this case, you'll have filtered out all the alarms for one certain farm or certain asset models through that farm or through your portfolio, entire portfolio. Each of the alarms that stops the turbine will also be detected and stamped as a root cause alarm. And here you can easily extract the root cause alarms directly, and you can also see how it's categorized in different ways. Coming back to that, but it's something that is happening automatically. And of course you have filtering and search functionality here that can search out for a certain alarm or description.
Explain us how this works exactly. The alarm is found, but it's very complex to find the root cause of stop. For example, if you have 10 alarms doing exactly the same movement, how do you choose the root cause?
Yeah, so what we do is that we are looking on the operational state and the events and all that, just to determine whether you have a stop turbine or a stop asset or not. And whenever you have a stop asset, we will look into the alarm log to see to find the root cause. And regardless of that is through the SQL server, if you have that available, or through the OPC or any other interface that you have, that could either be explained easily or more complex, as you say. What we have done is that by default, we look for the first alarm that occurs in that period to determine the root cause by default. But you can add logic to it in case that you know that, okay, if these alarms occurs, then such and such. Because we can also, in the alarm list, when you set up the configuration, you can set priority to different alarms. So it means that if you have the different alarms, and then you set a priority for whatever that should be, that's something that is configured in that. And if that doesn't apply to your requirements, you can download that model. You can download and you can make the changes that you like, and then you can upload it, and then it will correct the registrations based on that. So if you want to correct that because you have more knowledge, then that's the way we do it.
You cannot do it online.
Do it online? Yeah, I can do it. I just log on as the base user, which is basically a normal user, and I don't have access to that, but I can easily do that if you just give me 1 second, and I need to switch this to default. Ooh. Alright, I'll just do it from here then.
It is possible to do it online, or you always have to download and upload it to make this change.
Yeah, okay. Because I think I know what you're aiming at. I just want to show you this application just very quick. We go through configuration. These are the asset models. These are all the different models that are installed on this particular turbine. Sorry, this installation. There are models for condition monitoring, or there are models for weather station, turbines, inverters, and so on. But let me see if I have one that is. Do we have Vestas here? I don't remember which one is installed. Just give me a second. That was not installed. This one. All right, here's the alarm list. The thing is that you can download this configuration. It will create an Excel file for you. Here it comes. And then you can do your configuration in this to change whatever that you want to do. These are just the alarms, and this is the configuration, and you can set priority, you can set categorizations, and so on. And then when you've done that, you can upload this configuration again, and it will take immediate effect in the way that you want to do it. You could do it, I know that we have ongoing that you can do it directly here in the list, you know, on the fly, but downloading this makes it possible to do larger changes as you do that. Okay.
Raw data remain untouched, and then you can apply algorithms on top of them, or it's always, where do you act, on the raw data or on a second database? Because, for example,
the SQL database, you mean? The SQL server?
I mean, for example, if we have a contract with a manufacturer, usually they have their own rules for calculating the availability.
Yes.
Or it can approach with another method, methodology.
Exactly. And this is what we do under the analysis part. So I'm just moving to the analysis. This is the way that we do it, because you can categorize this in different ways. This is on the demo source. There's a lot of categorization here, but normally you'll find 2 or 3 different categorizations. Like if you have a contract saying such and such, then you will calculate the downtime and availability according to that contract. Otherwise, we also do it according to the IEC standard, so it will be different ways of calculating the same figure basically, but in some cases in the contract you want to remove the slanting wing or the cable room wing or whatever it is that you need to take out of the equation. So that's what we do in the availability application. And in this application here, you can see that all the stops that has been detected is displayed here. It's a management application. It means that you can look at each of the stops. Here you will see that this has been detected as the root cause. These are all the alarms that has been occurring during that period of time where the stop has been. And I can easily here change the root cause. I can set another start time. I can say, okay, I can merge these together. I can split it in 2. I can do all sorts of management on the availability. And the reason for that is, of course, that this is used for following up with the OEM on availability numbers. And as you do that kind of changes, you should also do comments so that explain why you did it, so that you're in a better position when it comes to the negotiation about availability numbers. We can also, looking at the stop here, you can also look at very quickly on the lost production, loss revenue, average price for this during that period. If you integrate with pricing information, that will be all available directly here. You can also do trending. Sometimes that's useful in terms of looking at tags in that particular timeline. So this is just one way of displaying that. You can easily open this in a trend application, which is an analysis application. So it's very quick to go that way. You can also look at this in the timeline. Either for certain assets, here you can see there is a stop, and then you can follow up on this, or you can do that on all the assets that you have. And this also affects the assets that you select here in the filter, so the filter always follow you, so that you don't need to do this over and over again. let's see if that opens. Opening up there, I'll just move on. Alright. So statistics analysis here is also quite important when it comes to not just the alarms that I was showing before, but also in terms of the stops, which is now categorized either according to the IC or your own contract. You can switch between, and you can see that there are different ways of categorizing these alarms. If you integrate with price information, you can see here that you get the lost revenue directly here in the list. You can also click on the different parts to get more detailed information on each part. And down here in the list, you will see all the different stops in their categories. And you can click on them in order to get the distribution of the turbines individually. And you can also switch this very easily the other way around. So you're looking at the assets. You get all the assets for that period of time that you have selected. And then in the list you'll see all the turbines, and then you can click to get the distribution of the categories for that particular turbine. So here it's very easy also to switch between different ways of categorizing or presenting the losses. Either that's in frequency, duration, energy, and different ways of presenting that, of course. All the applications that we have also have an export button up here, so this makes it very easy to extract the data that you have searched, either for a certain site or cross sites, to Excel to do more ad hoc type of analysis on the data. Alright, so I'm moving to the next application. This is a power curve application that will give you the opportunity either to compare between turbines in time, or you can compare the same turbines in time. You can save the fitted curve. You can do various things here. You can click use here, which will basically create mathematical formula automatically based on that particular fitted curve, and it will be transferred to the calculation service automatically, so that it starts calculating the theoretical production based on the anometer on the turbine together with the mathematical formula. Alright, so in this case here, this is an analysis tool, so you can select the time period that you want. You can set a certain wind direction if you want to filter out for a certain sector. You can also filter out data points if you want to, just to remove outliers if you have that. So that whenever you do that, it will be removed from the data set that you're using.
Something to do with the internet here. Just let me. I just see that sometimes it turns very slow. I think it's I just only open hotel network, so just let me switch to my. Any questions so far? As I switch. Sorry, I forgot to start my timing here. How is timing?
We're in the Mediterranean. It's pretty
Okay.
Look at their eyes. If they feel sleepy, it's time to wrap it up.
Okay. I'll just continue then, and please interrupt me if you have questions. Okay. Yeah, as you can see here, I think this is from the northern countries, so this is kind of icing conditions. I can filter out this by simply removing the outliers. And as you can see, then it's all taken away, just to get a smoother curve for the fitted curve. And the reason for that is that is of course that I can use this also for detection of performance. So in case of that I want to be alerted whenever something occurs, then these alarms will be triggered, and you can also distribute this to the rest of the turbines with the same model and so on, just to get it quicker up and running as a default. You can always download the configuration and make changes on it. So you can do it much more sophisticated than this. But it is a starting point where you kind of trigger on the bigger changes. So all of these alarms that are detected here, they will also go back in the alarm log. Same as we did here before. You will see them as performance issues. If we have that for this, so if you have that for the certain area, then it will be displaying here. So I just want to show you. So these are this is the alarm log and the statistics on that. As I showed you, that was the root cause. And the same applies with this as for the stops. You can look at the alarms and do alarm analysis, just as we did with the stop and the availability numbers. And you can also do this both on performance, but also on condition monitoring here. Let me just see if I have something. Might be that I need to go a bit further back here. Oh, it is. Here it is. All right. So you see that you have different conditions
that has been set up. And in the same way as we did before, you can do distribution on how much each turbine is affected by these conditions that you set up. And this calculations, that's something that the software offers, so that you can set these up yourself as well, in addition to what we come up with as a part of the product. So that's another part of the product. Another thing that I didn't show you before was the ability to map this. Of course, there are possibilities just to looking at this in different ways. You can right-click here and you can change some of the configuration regarding whether you want this to be displayed in different ways, basically, with different type of information, of course. It's just another way of monitoring the data. All right, I'm moving back to the analysis application here. We looked into availability in the power curve. There is a trend application available with the possibility to look at this in the timeline. There is also an application here where you can look at data, two-dimensional or three-dimensional. I can just load one that has been done here before. Let's see if that's... So in this case you have power and pitch and power and RPM simultaneously. And you can change this to be for another time period or certain other thing. The filter here, which I kind of forgot to explain on the power curve, is the ability to do conditions. So that means that you can set, based on tags, say wind speed above 10 meters per second, or only when the operational state is in run, or whatever type of combination of these type of conditions that you want to set. So that's something that you have flexible here in order to extract or filter out the data itself when you're doing trending or XI plotting or other application where conditions apply.
Do you figure out very common to see in centralized database? For example, an anemometer was frozen and it destroyed all your analysis. So if you can't change this data, you can't work usually.
So you want to exclude whenever there is bad data, sort of.
How do you manage it online?
We can do calculations so that it always compares between like a condition on the anemometer. So when there is a poor measurement, then it will be triggered. It could be, if I show you a bit on the conditions here, you can also do this if you set up the wind speed, take that as an example, and you look at all the wind speeds simultaneously. You will notice that, okay, some of these areas are red, so it's probably something with an anemometer. And you can do this, or you can do it by calculation, so that you do it automatically. And you can then create notifications or alarms or whatever you want to be displayed in the applications or through statistics. But the thing, if I understand it correctly, you want to have an identification of when it occurs so that you can extract that easily from your analysis.
I don't know if it's the solution. I know that it was usually depending on the system that you're using, you're trying to find either to rewrite the database or to export the data and perform an analysis in Excel. But in some cases, what we do is we identify the problem through a notification, and then somehow we need to either change the data or delete it or exclude it, put a flag and exclude it from an analysis.
Yeah. That's something that we normally do automatically, so that you don't do that manually. But I see your point, and it's a valid point, so I'll bring that back with me. I just wanted to make sure that we have that in the roadmap, so that we don't. Yeah. So, but this is just another way of presenting the conditions, as I mentioned on the. In the asset operation application. So in terms of looking at gear bearing temperatures or whatever type of variables that you can compare between the turbines that you have available in the timeline, just as we did with the PV inverters, makes it very user-friendly in order to look at periods where you have abnormal values, and these are areas that is also detected automatically by calculation, so that it can be taken up as statistics. And by default, we do this with all the temperatures, but also we do it with the yaw misalignment, trying to look at areas where you have situations like this where you're in a bad situation. The occurrences like this is when you don't have data. This is just on a demo server, so it's a bit messy. But if you don't have communication with the turbine, or there is a stop on the turbine, it will be presented like this, so that you don't look for turbines that are stopped in the first place, because the nacelle is not aligned correctly anyway. Another thing that this module will do is that it will give you the opportunity to look at and compare between assets. So we're using the heat map here, taking all the temperatures available, for example. This is following the same technology as we had before, so that you can look at or you can add any widget if you want more or less, or whatever you want to do with the dashboard. You can very easily do that. Same here. It applies with conditions. So say that you have a certain tag that you want to extract. Winds more than 5 meters per second. So if I apply that, it will remove those areas. You can see there are shaded gray areas here where the conditions are not fulfilled, just in order to compare between assets, basically looking for abnormalities. So here you can select a range of assets and just do comparison in time. There's also a set of pre-configured applications, like this is pre-configured with condition monitoring, and these are the alarms and so on. So I think I've already shown you that, so I'm not diving too much into that. Another thing here is that we also do a range of different calculations in Bazefield. That means that, for example, production index or performance index, capacity factors, and so on can also be here presented in the same way with the heat map, just in order to have that visualization of each of the performance issues that you would like to follow up on. And the same applies here with performance, that you can do comparison between the different assets itself. All right, I'm diving into I think the last part, which is reporting. Just wanted to take a very short dive into that. There are some, I would say it's divided into two parts, basically. One is the reporting elements, which is kind of seen as a kind of a library of elements that you have to or that you can use as a source of visualizations. So you can basically pick various type of visualizations like this in your reporting. Either that's tables, graphics, statistics, as I've shown you in the stop or availability analysis, or the alarm log analysis. These are elements that you can pick and you can put in your templates. And that's the other aspect here, because in the system there is a range of templates available that could be on daily basis, weekly basis, monthly basis, as you can use as a starting point for your reporting. And then you can make use of the library in order to make changes to the reporting as you like. We do training of users. In here you will find all the documentations available so that you can tailor this based on the reports, template reports yourself. So typically, if I look at, let's see if I have one here. It's getting a bit messy with the administrator here. Okay, so this is just one example, very small example with turbines in stop state, turbines underperforming, the 10 lost stops, last 24 hours, sorted by lost energy. That's just one setup that you can upload, and it will give you this report. It can also be scheduled, of course. You can create a PDF if you want to. You can send it to email, or you can it to be sent out every morning to your mailbox account. Another example is a weekly report here. Let's see if that's available. The reporting here is all web-based. It means that you can also do your comments directly here in the reporting, and then you can save this together with the graphics and so on. So it's dynamic as long as you open it in the web. And then when you generate the PDF, of course, you can store it in the system, and it becomes the official static report that you have available. Also, just a very last report there. There's a monthly report that's installed here, I can see. So in this case, you see that you have an executive summary, you have some health and safety issues. These are just budget numbers and production. Okay, let's go a few months back just to get a little bit better data. It's just a very early start in the month, so it just doesn't have much data. So, but you get the point. It's just a library of elements. You can put this together as reports, and you can then have all the type of visualizations that you want inside that report. The last thing I want to mention is the ability to do in the API. Investing in such a system as Bazefield, then I think it's very important that you think about this to have the functionality of an API, an open API that you can communicate through, either that's with configuration or extracting historical information or real-time information. Take the collaboration that we have with 3E. They can extract data. They can do a lot of more advanced forecasting algorithms, for example, and then they use the API to save the data back so that you always are updated on your forecasting. So having such an open system, you can plug in other stuff for your own stuff on top of that. We have quite a few people that are very, very sophisticated in MATLAB, for example, that are using the API to just asking for data for a certain period without going through files, because files just takes time, and you don't want to spend time on creating files and transfer files and so on. So it's much better just to use the API in MATLAB if that's the tool that you're using. Okay. I think that was the part that I prepared for the presentation of the wind farm management system. I also have a short one on the forecasting, but I think it's good to have a break in between.
First of all, thank you. Are there any questions, or you want to go for a coffee?
I'll be here. There was a question?
I wasn't here in the first part.
Yeah.
I don't know if I missed something.
Not a week. No shoulder in the morning.
So, what is the cost of this?
Yeah.
And how this Bazefield is connected with SynaptiQ?
Yeah. Okay. So 3E has a product that is named SynaptiQ, which is containing both for solar PV, but also the wind software as you see it here. They brand it as SynaptiQ, but it's basically Bazefield when it comes to analysis of the wind farms and so on. We have a cooperation so that we do this in cooperation. So they are much stronger than us when it comes to really deep understanding of the solar part. And we are equally strong in the wind domain. Regarding the pricing, that's a tough one. Just to give you that over the table. Because there is a range of inputs that we need in order to start doing that. And that's, I'm not saying that because it's I don't want to give it to you, but it's just a matter of the number of sites that you have and the number of turbines that you have. If you want this to be installed in-house so that you want to buy the license, or if you want it to be a hosted service that you buy you buy it as a software as a service, basically. That will have different. So you have a cloud solution or an in-house solution, which also affects the pricing and there are some things that we need to just sort out before I can give you some kind of indicative pricing. But I'm more than happy if I can send you an email afterwards just with the questions that I normally ask, and then we can certainly do a follow-up on.
Apart from the in-house and cloud solution, is there also a lighter packet? I mean, you sell all the services, or you can have a lighter packet that always will be so. Just asking, it's an idea.
Yeah. Okay. So we do. The pricing is also connected to which part of the system we have. We can divide a little bit and distinguish a little bit on the pricing. Simply because some of the owners that are using this is more financial owners. They don't really dig deep into the analysis part. They only want dashboard to follow on the big issues. So that's the reason why we have some of the owners kind of dashboards here, which is more focused on budget numbers towards P50 and how are each sites according to that and so on. So what we do is that we for each of these modules there is we can decide whether to turn it on or off. In terms of data logging, we always log the data with the highest resolution because we believe that data should be treated as an asset itself. So that's the reason for that. So we don't degrade the data whatsoever. But that just will also affect the price. That's what I'm trying to say here.
So you have a kind of initial investment, and then you pay some annual fee on the
Yeah, that really depends on the way that you want to. We have all the flexibilities. So what we can do is that we can take responsibility and buy a server for you, install it on that server, and deliver it to you in your infrastructure as an in-house installation. Or you, if you have the IT department, they can take responsibility for the server and the hardware. We just install it, but still you buy it as a license. On the other hand, we can provide you with Azure Cloud, which is costly, and even more costly if you want to do a Tier 4 security level. You know, so the security level also will play an impact. So it's basically it's very hard to just say a price, you know, for that, but. Yeah, these are the things that I can send you an email and we can discuss it from there. Okay. Okay. Any other questions?
10 minutes coffee break in that. Okay.
All right.
Δεν είχα κάνει το αιωλικό πρωί, τα απόγευμα πρόβλημα. We were all here, more or less. If you can switch on the microphone as well when you go. Yes.
Hello?
Yes.
That's good. You can hear me?
Yep.
Eunice?
Yes.
Okay, I have one last part, which is about forecasting, and I was thinking about just show a few slides in the beginning, just explain the how this works, and then move to the demo server, just showing you a few screens and a few applications there where we make use of forecasting in real time. All right, so We had here from before presentation by 3E about the forecasting. The way that we look at this is to get the best forecasting in as possible. You need to work with it. You need to work with not just the models itself, but as Trey also mentioned, you need to work with the meters itself. You need to be in control of your models and the weather conditions, of course, weather forecast and availability. So that's what I'm going to take a little bit dive into, how we do this in a practical way in real time. As I mentioned before, I think one of the changes that is ongoing, and we see it in countries. Take Ireland as an example, where you have a really high market share of renewable. You're constantly being curtailed. You cannot produce as much as you like at any time. So in these countries, it's also very important that you're balanced with your forecasting and that you're producing according to your schedule, and there's more heavy penalties for not doing so. And we also see it in the UK on the bigger sites that that you need to be updated at all times. And for the biggest sites now, it's about real time, and that's what we're trying to do with our solution that provides these updates in real time. So if there is one of your substations falls down, or a string or a turbine, then it needs to be updated in real time, basically. So there are three, and that's what the three elements, I would say, that is affecting the accuracy of the forecast. And I'm trying to elaborate a little bit on that during this few slides. And then I'll move on to the demo. You'll see it here in the here to the right. It will be. Yeah. You don't see my mouse pointer, so it's not needed for me to show that. But it starts with availability. So you need to be in control of your assets, not just with the corrective maintenance, the corrective stops that occurs, of course it occurs, but it also deals with availability into the future, meaning planned maintenance. So that will have a big impact on the accuracy of your forecasting, of course. The same way, you also have an impact with the models, and you can build simple models, you can build more complex models, you can build neural network, you can build black box, whatever, and you can really spend a lot of time and a lot of effort and a lot of money on doing so. We have maybe a little simple approach to that, but it's a starting point that we have found is very useful. And it's also useful even though you have a third-party forecaster on the outside, because then you can use our a little bit more simple model as a benchmark for that external owners or external forecaster. So we see that some of our customers, especially in UK and so on, they're doing very sophisticated models on the outside for the bigger wind farms, and then we use the simple model as a benchmark for for the forecasting. Of course, weather forecast is also very important, as we have been told here earlier today. I'm not doing lots of effort on that part now. Just wanted to mention that there are different options, and that we also, since we're an open system, Bazefield is an open system that can transfer the data in real time, and we do that for some of the sites, so that the weather models can be not just tuned to local conditions, but as you gain more and more weather information, that information is transferred continuously to the forecasters so that they can tune their own models in real time. Alright, so that's the introduction of that. This is a little bit an overview. It's a kind of it's a bit messy, I agree, but it still is a overview of forecasting. It's kind of divided into two parts. It's the operations planning that will affect the availability. That's one part of what we're doing. The other part is when you turn availability and combine it with weather forecasting and the model to create the production forecast itself. So either way, you need the availability plan in real time, and then it depends on whether you want the production model to be inside Bazefield or outside Bazefield, basically. I will come back to this later. Okay, I think I'll just switch to the demo for now. So just give me a second to load this up. I just need my I need to charge it because I switched to my
mobile phone, and it's about to go out of batteries, of course. Yeah, if I just need this one. This one, yes.
Okay, back again. Feel free to interrupt me if you have any questions related to this. Oops, this is not the things that I'll show you, of course. Where did it go? There it is. Alright, we went through the monitoring and analysis and some of the other modules here. There's one module left here, and that's what we call operations. In here, you'll find some applications that is useful when it comes to being in control of your availability. This is an application, we call it site activity, which means that either we integrate with the maintenance system so that you have all your work orders in here. We've done that with Xerion, we've done that with IFS, we've done that with SAP, even though I must stress the fact that even if you have an integration with SAP could be very different from different installations. So you need to be aware of that before you start such an integration. But nevertheless, this list shows all the work orders that are planned into the future. And in addition to that, of course, resources planning, who has been access this or access rights to the site and to do the maintenance, You can set up alerting and so on with this site activity, but that's one part of this application. Is just for the safety and security-wise that you need as an owner to be in control of your assets. It means that at all times you need all the planned work, who has been scheduled for each of the maintenance, who has access rights to the turbines as we speak. If this person here is completed with his work, he can easily log off, and that will be removed, and the control is back to the control room. So that's one of the aspects. The other aspect is that as you work with the work orders and you integrate and you get all that information in here, it will also affect the availability, not just in real time, but also into the future. So here you can see that the work orders has been scheduled for a certain period of time into the future, and that will affect the availability, a matrix of availability, I would say, that is either sent to an external forecaster or is being used internally in Bazefield to produce the production forecast. And you can do this on a site level. You can do it for the substation. You can plan for downtime on the assets and strings and so on. It's just a way of planning this. That means that based on that information, together with the corrective, so if something stops, you will see it here as a unscheduled task. Normally we set up a default so we know that if a certain turbine stops, it will be planned for 2 days by default. That is going to be done. But you can set this up as a configuration so that you if that's only 1 day for you or 5 days, that's totally up to you. The next thing here is then the ability to look at the training and forecast. Of course, this could be external data. They could also be Bazefield data. In here, still you have the opportunity to filter out. So if you have only wind farms in a certain area or a certain country or whatever, then you can take it out so that you have your forecast for that particular area. So what we're looking at here is basically two different parts. You have a production and you have an availability. And again, this is just on a demo server, so it doesn't fit very well, as you can see. But in here, you will see that you have a vertical line which indicates now. So this is current time. To the left, you have the availability, the real availability, and up here, this is the planned availability. So whenever there is a difference here, that's what you're trying to avoid, because you need to be on guard when it comes to availability, because that affects the product, that affects the accuracy of your production forecast. On the top graph here, you will find the production graph, which has basically 3 different elements. It has this yellow or orange line here, which is the maximum export capacity. It gives an indication in some of the countries where you curtailed. So whenever you curtail, you're down and you shouldn't produce more than that. It means that something is wrong in your your algorithms or in your control system. So that's the reason why it's up there. In addition, we have the production and the production forecast. And by default, we also add kind of a slope around the forecast here into the future, which indicates how much inaccuracy you have in your data for that period. That is something that we set up by default, as I said, as a fixed value into the future. So the slope is kind of a percentage of your, based on calculations, of course, but it's something that is done once. We can also do this continuously, so it's learned, but that's more like a project that we can set up for you. But you can use the calculation engine and the modules, and you're free to set up as many calculations as you want, of course, but that also has a cost in terms of performance on your service. So, okay, so that's the forecasting and the presentation of that. As you can see here, it's very easy to switch if you want to go further or deeper down into the details. And of course, filter. What we also do is that we try to keep track on the accuracy. As I mentioned, the slope that you have is also affecting the probability of reaching that exact forecast. So what we do is that we have a kind of a very simple approach to it. We just calculate the mean forecast error, which indicates if you have a bias to each side. So if it's continuously, it should be around 0, so that you don't under forecast or over forecast. If you do so, then you should look into the models again. So, and this can also be set up with alarms so that you are notified whenever there is a big bias in your forecasting that should not occur. Another thing we do is that we calculate the absolute deviation, mean absolute deviation, just to look at the error itself. And we also use a very simple approach to a tracking signal, just a calculation that should be close to 0. If it's more than minus or plus 4, then it's kind of where you want to look at the models again, because then you have a bias in your forecasting part. And this could be applied to any forecasting that you have included. For example, here is the wind speed, the weather forecast. That's not generated by us, it's just logged, but still you can use the calculations. And the other thing is that you have an actual and the production forecast and the errors for the production, and you have the same kind of approach to it for that. So, and of course, we also have quite a few offshore wind farms. So in that case, if you have wave heights, and often they are displayed in different parts of so you have probably 4 different areas at least. And then you can track the forecast for each of the areas and so on. Just not necessarily to get the best production forecast, but just to it's used for operational purposes, so that you know whether you have access to the turbines or not. So that's about forecasting. Of course, all of the data that comes either from external weather forecast, like this, comes from an external that we integrate. So we integrate either with a kind of free of charge, not necessarily the best weather forecast. If you have your own weather forecast services that you already have a subscription on, we will integrate that for you. These are kind of very easy and straightforward integrations to do, often using files. Of course, we also, as I said, set up more sophisticated, more adaptive approaches to learn and train models continuously with integrations. That's the third option, and would become, of course, more costly because it requires someone to follow up, and you have an extra integration and all of that. So it depends on how accurate it needs to be in terms of a cost-benefits approach, of course. So sometimes we also, if we integrate with external forecaster, we often then also integrate with the production forecast coming back, so that we also log that data. In terms of forecasting data, we can log both values like this, but we also log the vectors, so that you continuously have all of that data in your database. So that's the approach that we have on the forecasting part. As you can see, it's real time. It's something that is, I would say, very focused on these days in various countries. As more and more renewable is added to the grid, and it has its effect on the grid, of course, and you need to be more accurate. Any question regarding forecasting? All right, yeah.
When you say that you integrate and you just take widgets, or do you do something more complicated in the farming direction? Up to what level can you go?
Yeah, okay, so by default, if I switch back to, I think this is a way of resembling that, because the model can be very kind of simple, where you can use the power curve, and you can use the weather the wind speed forecast, and then you can aggregate that. Of course, if you have a 3-turbine site, it might work for you. If you have a big offshore 88-turbine site that's at the east coast of England, that's probably not going to work for you. So we have possibilities to add more logic to it. That will be a project up to a certain point. We could integrate with neural network, and so on. We have that kind of competence in house. But I would say that we, as I said in the very first slide, or one of the first slides, we try to be the best software provider, and we try to focus on the product and not necessarily on that kind of consultants' hours that needs to be in order to tune in a model or something like that. So what we do in those cases is that we use 3D, or we use REDPro, we use various other partners that we have out there in order to solve that issue. Or if you have a preferred vendor yourself, that's something that we can integrate with, of course.
Okay, but the software doesn't have the capability to integrate this information done by whoever third party.
Yes, and that's a very important part, I think. It needs, such a system needs to be open. We cannot hide behind a wall here, so that's crucial. Right? Any other questions?
Yes. I think it was mentioned before that the forecasting module can be provided independently, correct?
Yeah, we can integrate with an independent provider of that, of course, if you have a preferred one, or we can do more advanced, as we had the presentation here earlier today.
As a standalone service, is it possible to serve only the forecasting?
From us, you mean?
Yes.
I would say almost no, even if I hate to say no. But
maybe, sorry to interrupt,
yeah.
We do forecasting and we provide that in the system of both solar and wind, so we have our own forecasting algorithms, so that's perfectly possible. Okay.
Yeah, I'm just telling you, on Bazefield we say no, but we are in a partnership here, so that's it.
So we provide forecasting both for solar and wind, and that can be separate from SynaptiQ and Bazefield if you have your own system.
Okay, you mentioned before that this the system can be installed even on a server owned by us and function independently from as a standalone program. Is it possible to work in an offline because here we show that if it is integrated directly with the plans, the algorithm of course works better, but for a case that we want just to feed manually data and take a forecast.
We don't recommend that, but if you want something which is suboptimal, okay, we're ready to provide that. Maybe Mauricio or Vasilis can comment on that. But the more integrated your system gets, that's what Mauricio said during his talk, the more performing it gets. But as an intermediate step, I don't see any problem to have it separate as an intermediate data flow in your system. But of course, if operational data are not matched with the rest, your quality of performance follow-up is less good. And I advise to at least have a roadmap to go to something fully integrated, even if it takes some time to do so.
But to complement, indeed, we can provide forecasts as a standalone service very easily.
We do so. So Mauricio's team is doing at the moment, so you can have data flows just on that topic, independent of Bazefield 3E performance monitoring. So
another question. You mentioned that the algorithm is self-learning. Let's say it reads the data coming from the plans and can further develop.
Yeah, okay. Self-learning in this, what I mentioned there is that the integrations that we do with external forecasters, that has the self-learning algorithms. We do not have that in the default installation that we do in Bazefield at the moment. But there are capabilities of doing that, but that's more like project oriented, and we try to kind of avoid that kind of implementation. We like to be a product company. So
the operation data coming from the client, for example,
yeah.
do they affect the algorithm itself?
The way that it works is, for example, you have a black box model on the third part, right, sitting over there. And what we do is that we provide that black box model. That black box model is trained by 6 months of data. It's not enough. It should be a whole year or even 2 years of data. So what we then do is that we feed that in real time with the model, the black box model, and it starts to learn from the history. And then over time, the forecasting will improve. Okay, and then the results of the forecasting will be sent back to Bazefield to be logged, so that you can have a real-time accuracy calculation on it. But the training, the self-training, is done in the around the black box models.
When you buy a software, you buy also the black box?
No, that's what I'm trying to say. That if you're aiming for the Bazefield system and use only the default models, that's more a fixed model for your for it. It doesn't have the accuracy of a black box model. How much you will gain depends on the complexity, of course, on the sites and a lot of other aspects. But what we recommend is that you still keep the simple, I call it simple, model inside the Bazefield system. It just runs. And then you can train the more sophisticated model, self-learning, neural network, whatever type of artificial intelligence that you want to put into it. And then the result of that comes back to Bazefield so that you can benchmark it towards the simple model. How much accurate are you? How much is that costing you? Is that the cost benefit? Does that really, is that a good calculation for you or not, financial wise?
Just to add to that, and maybe you also can comment, we have a team of about 10 people working mostly on data mining, artificial intelligence, technology, and that's integrated and available for the system. So,
as a plugin, yes, you can certainly do that. Of course, it has a cost, of course, to train the models and so on. But that's again back to what Gert said earlier about how hard are you penalized when you're wrong with the forecasting.
Yes, and there, for example, on the beginning we offer different types where you can, for example, just train the model once, having a lower entry price for certain applications. But you have more advanced models that can be trained multiple times throughout the year, or even with a feed of data, recurrent feed of data, that they can be automatically retrained. So depending on the needs, we can feed different types of work.
All right. Any other questions?
Is this included in the base module, the forecasting?
Forecasting should be is included in a standard Bazefield installation. Yes. Any other questions? All right, Jonas, I think that was.
Thank you very much. Thank you. I think I will give the floor to Gert now to wrap up, and then I will.
yeah, so thank you very much for the broad presence and high-level people around the table knowing a lot about asset management in wind and solar.
Speak up, please.
My voice is. Do you understand me? Normally.
When I was there,
Okay, but you're getting old.
sounds like
These are young people, you're getting old. So, but no, I really appreciate the presence of all of you, of different companies, top level in Greece. I'm a strong defender of Europe, and I know Greece has had difficult times throughout the years. And I'm very happy that we kept Greece on board and that we didn't choose for Brexit. But on renewables, I must say that Greece was one of the forefighters in Europe on renewable energy, so that's great thing. But I hope we can collaborate with our team and the contact person, the single point of contact for everything you want to get out of this is REDPro. We have a strong collaboration jointly with Bazefield 3D, backing Giorgos team, which is growing, by the way. So if you have any concrete question, please, REDPro is the concrete single point of contact, but as you see, we're here with 5-6 people, and we will be here on a regular basis to support the Giorgos team to get your things done in a practical way. My contact details are available, but yeah.
So, we should thank you for showing up this difficult week, especially some people who gave up their holidays or whatever you do this week, so thank you for coming. Enjoy the rest of the week, enjoy your holidays και καλή ανάσταση από οτιδήποτε σας καταπιεστεί και σας καταπιέζει. Να είστε καλά.